This is a picture of a dune buggy, a toy dune buggy. A bad picture of a toy dune buggy. A bad picture of a toy dune buggy with something taped on the back of it that then goes through a weird little machine. Oh yeah, this is a picture of the physics lab. Let's look at it in a little more detail. Okay, this is another picture of that same dune buggy, bad. It's going to be in motion in a second, so watch it. And a shaky camera, and the dune buggy goes, and that weird thing on it goes through that other thing. Wow, that is strange. Let's go back and look again. Dune buggy, sitting there. Dune buggy goes, and it pulls on something that's going through a machine. Got it. Okay, let's look at the lab in more detail. So in this lab, we want to find the relationship between the time that the dune buggy travels and the distance that the dune buggy travels. Cool. To do that, we're going to use some machines. And the first machine we're going to use is something called a spark timer. So the tape is right there, and it's going through that opening underneath these copper wires that are right here. The copper wires have a small electrical current going through them, and that electrical current sparks or jumps off the wires over to a plate right underneath them. When it sparks, it goes through the tape, causing a little bit of heat. That heat, because this is heat-sensitive tape, will cause a mark. So every time you have a spark, you get these two marks on the tape. Now, there's two switches on the spark timer. There's this one right here, and there's this one right here. This one right here is the on-off switch. This one right here gives the frequency that the spark is generated. It can be at either 10 Hertz or 60 Hertz. We're going to want to make sure that it's at 10 Hertz. So be sure that it's over here to this side on the 10 Hertz reading. If it's not, you're going to be collecting an awful lot of data. When the spark timer is at the 10 Hertz setting, it means that for every 1/10 of a second, a spark is generated. The tape is attached to the dune buggy, so the dune buggy is going to be zipping along that way. And as it zips along that way, it pulls the tape with it. And as it pulls the tape with it, every 1/10 of a second, another set of marks is made. Unfortunately, running the dune buggy and getting the spark timer tape done is a very, very short part of the lab. After you get that done, which is the kind of the fun part, you're going to go to the data collection part. So let's look on at that. Right here we have a used spark timer tape. These two black dots right there is where we had the spark timer turned on and the car not moving. And you want to do that. You want to turn the spark timer on first and then turn the car on. So we're going to disregard those marks. We're not going to pay any attention to them. They don't exist. We're going to use this first mark right here as the first mark, or the origin, or the starting point that we're going to measure from. So there was these two really sloppy marks, and there's a couple of marks in between that look kind of strange. And then there's a short gap and then a more reasonable gap. So it's between this short gap and this more reasonable gap, we're going to decide that this guy right here is the starting point. So this is our 0 reference point. Once you've run the dune buggy with the tape and gotten it marked, you're going to take that tape, you've decided where your 0 point is, or your line, and I went ahead and drew a line on here so it'd be easy to see with the camera. Got that messy area right there. And then I went ahead and marked where all the other dots are, so I found every place where there's that pair of dots right in there. And I marked it. And now what I'm going to do is go ahead and go back in there and measure the distance from the 0 point to right here. Okay, that first distance is the distance the dune buggy traveled in 0.1 seconds. So this was 0 seconds, this was 0 seconds, and this is 0.1 seconds. And then I'm going to measure the distance from 0 meters to right there. And that's the distance that the dune buggy traveled in 0.2 seconds. And then I'm going to measure the distance from the 0 point to the next mark. And that's the distance that the dune buggy traveled in 0.3 seconds. And then I'm going to measure the distance from the starting point to way over here. And that's the distance the dune buggy traveled in 0.4 seconds. I'm going to go all the way down until I have 40 bits of data. So I'll have 40 pieces of data. After I get done taking all of the data, so what's the data I'm taking? I've got the seconds, 0.1, 0.2, 0.3, 0.4, and the distance traveled in that time. I'm going to put it all into a column, and then I'm going to go to graphical analysis. On graphical analysis, I'm going to put in my x variable, my independent variable. I'm going to put in my dependent variable, and I'm going to put in all of the data. After I get the data in, I'm going to do a best fit line, check to see if it's linear. After I do that, I'm going to write the relationship or formula between the dune buggy distance and the dune buggy's time. After I do that, I'm going to staple it all together and hand in my lab, because you'll be done. Thank you very much.